Hello students, hi, I hope you all are doing well at home. Welcome back to the mathematics class. Here we are for grade 9 today, mathematics, and chapter today we are taking 13, that is surface area and volume. This chapter along with chapter 12 comes for 13 marks in CBSE board exam. So this chapter is equally important, and whatever you will be learning here, same thing is in grade 10 also. That's why it is very important. So today we'll be learning in this chapter about surface area of 6 type of figures, its volume, and we'll work out few questions and examples under that. So whenever we call it shapes, there are varieties of shapes, but here we'll be learning about 6 shapes only, that is cube, cuboid, cylinder, cone, sphere, and hemisphere. Let me start with cube. This is a cube. I believe you at home you might be playing Ludo. There also you can see this kind of dice. So this is a cube in shape because its all faces are made up of square, and there are 6 faces, 4 in the lateral side, 1 on the top, 1 in the bottom. So 6 faces are there. This is cube. Similarly, this is an example of cuboid, where 4 faces are there, up and down, 6 faces, but it is made up of rectangle. Difference between cube and cuboid. Cylinder, I have one example, this pack. You might be having at home certain example like glasses also. It is cylindrical in shape. Here cylinder, you can see it is not a straight line but a curved face is there, and on the top also circle, down also circle is there. Cone shape is like this, slanted face on the top with a curved part, and in the down circle, base we call it. And similarly another shape is sphere. Sphere, you can take example of ball, you might be having at home also. And for hemisphere, if you cut that ball in half part, it will give you the shape of hemisphere. For example, bowl also at home in your kitchen you can find it. So regarding these 6 shapes, we will be learning its surface area and volume. So whenever we call it surface area, remember there are 2 types of surface area. One, lateral surface or curved surface we call it. Another, total surface area. For example, for this cuboid, if you take it, its lateral surface area, if you say, that means the surface area which you can see from the side, excluding top and bottom, that is what we call lateral surface area. For here there are 4 sides of the square, so its lateral surface area will be 4 times area of each sides or each faces of the square. Now we will be learning how to calculate the formula. Here formula is very important and it's a key point in here in this chapter. If you learn the formula well, it will be very easy for you to do the question. This is cube. I'll be making in the board also. It's a 3D figure, 3 dimension, where length, breadth, height, everything is involved. So this, since it's a cube, all the sides are equal. Length also equal, breadth also equal, height also equal. So I am taking A. So if it's lateral surface area you are finding, remember for the calculation of LSA or CSA, there is a fixed formula, and the formula is perimeter of the base into height for that particular figure. For example, for cube, it's LSA, perimeter of base into height. Now in this cube, what do you think its base perimeter would be? Obviously it's a square. So perimeter of square will be taking, because you can see base is square in shape. So perimeter of square is 4 into A, and height. In this figure you can see height is also A. So into A. So that gives you 4A square. This is how LSA has come up. You need not have to remember this all. You just remember LSA formula as 4A square. But the key point is, in any figure ever you want to find LSA or CSA, remember it is perimeter of the base of that figure into height. Now similarly, when we calculate its total surface area, we call it in the short TSA. TSA. For total surface area, you will take CSA also and remaining whatever area is left out. For example, in this cube, LSA you have already found out 4A square, that you will take it and remaining everything. So whenever we call total surface area, including top and bottom as well. So here 4 faces we got 4A square. Top 1 square, down another square. So area of 2 square will be A square plus A square. So how much did you get for TSA? 6A square. So this is how TSA is calculated for any figure. Now when we call it volume, if you want to find a volume for the same figure, volume of any figure is how much quantity it can contain in it. How much quantity of matter it can contain in it. So now volume comes in various words. Sometimes in the question you might be hearing digging. Earth has been dug out. Sometimes in the question you can see something is filling up. A soup is filled in the cylindrical bowl, they will be saying. So filling, containing a certain quantity of matter in it, we call it volume. So for volume, it also has a fixed formula, that is area of the base into height. So in this figure, base is square in shape. So it's area. Area of base into height. Since it's a square, area of square is A square into height is also A here. So that's why into A, that will give you A cube. So LSA of square is LSA of cube is 4A square, TSA is 6A square, and volume is A cube. This is how it is calculated. You can note down this formula, or I'll be even sending it in your PPT as well. Now similarly we'll be doing for cuboid one more and one for cylinder. Remaining everything is calculated in same way. I'll directly give you formula. So this is a cube. This is a cuboid. So this is a cuboid. In a cuboid, you can see the faces are made up using rectangular faces. So in a rectangle we have length and breadth, but since it's a 3D figure, there is a height also involvement. So we will be taking this as a L, this as B, and this as height. In this figure you can see here, this face, this line will be length, this would be breadth, and this would be height. So when we want to calculate its LSA, use the same formula which I have told you before. LSA for any figure is perimeter of base into height. Now, for this figure, what is the perimeter of the base? Obviously, it's a rectangle. Since it is a rectangle, its perimeter will be 2L plus B, which you have learned in grade 8. Into height is in terms of h, so we'll write h only. So this is the LSA of cuboid. So when we find TSA, like before, LSA also you will take it, that is 2L plus BH plus whatever faces are left, those area also we will take it. So when we call LSA, only these 4 side parts has been taken, excluding top and bottom. So now we need to add top and bottom's area. What kind of shape the top and bottom is of in here? Obviously rectangle. This is a rectangle. So for rectangle, this is length, this is breadth. Then its area will be L into B. Similarly down also L into B. So here LB plus LB. 2 faces, that's why I am adding 2 times. Now this is the TSA, but we will try to put it in little bit simpler form. Okay. Now we will multiply these 2 and bring out of the bracket. 2 into L into H, 2LH, 2 into B into H, 2BH, LB plus LB, 2LB. Now everywhere there is a 2, let us take 2 common and put it in simpler form. So 2 common, LB in the front, BH in the second, and third HL. LH or HL, it is same thing only because they are multiplied. So your TSA is 2LB plus BH plus HL for cuboid. Now in the question always LBH will be given, they will be asking you to find TSA. Now whenever we call a room, sometimes in the question they will be asking like this. What is the cost of painting 4 walls of the room? Now 4 walls of the room and their length, breadth, height will be given in question. So whenever LBH given, you can automatically remember it is a cuboid. And they have clearly said the cost we need to find for painting the 4 walls. So 4 walls means only this 4 lateral surface area excluding top, that is ceiling, and the bottom, that is floor. That means they are asking you to utilize LSA formula, not TSA. So like that you have to distinguish clearly between LSA and TSA. Sometimes before in grade 8 your Cambridge checkpoint exam, you're asked to make a dog house, if you remember. So some of you did a quite mistake in there, and some of you while sending, for example, Akash is there in grade 9A, he sent me one of the doubt, and there he was not very clear with the concept. So I told at that time also to you all that I'll be teaching this chapter and I'll make you clear with the concept of LSA and TSA. So here that's why you have to be very clear with this concept. Remember, LSA is only 4 sides. TSA is including top and bottom and everything. Whatever extra areas comes up, everything you have to take. For a cuboid, no problem, only 6 faces. Sometimes figure would be on the top, you will be making another triangular shape. Then its area also you have to find. So like that, TSA means every area of the faces which you can see in there. Now we have another, that is volume. Like before, the volume for any figure is area of the base into height. So what kind of base does this cuboid has? Rectangular base. So area of that rectangle will be L into B into height. So height out here is H. So that means formula for volume of cuboid is L into B into H. So this is how we can find the cuboid formula. Now one more we will do calculation, that is for cylinder, and remaining I'll directly give you formula so that it's easy for you to remember. We'll not keep on deriving every formula. Third one we have is cylinder. So this is a cylinder. With me right now only this figure is available. This is a hand sanitizer. You all have been using it at home also right now because of this pandemic situation. So I have taken a very relevant example. This is a cylinder. You can see this face is a curved part. It is not a lateral, not having a line segment. Since it is a curved part, we do not call it lateral surface area. We call it curved surface area. This part, CSA. Now follow the same formula, CSA of any figure. Since it's a cylinder, there is a circle involved, there is term radius, because whenever circle involves, radius always is there. So we write it small r, and the height of that cylinder, small h. Okay. So for any curved surface or lateral surface, we have a base formula as perimeter of the base into height. Now in cylinder, what kind of base does it have? Clearly you can see here, circle. So what is the perimeter of circle? We call it circumference of the circle. In question the word circumference will come. Remember, circumference and perimeter mean same thing for the circle. So circumference of the circle is 2 pi r. You have learned before. So in place of perimeter you write 2 pi r into height is in terms of h, so h. That means 2 pi r h is your CSA. Now TSA let us find. For TSA, CSA also you will take whatever it is plus whatever area left. If you can see here, clearly upper circle and down circle area is left. We have just taken this part excluding top and bottom. Now top is also area, bottom also is area of circle. So area of circle is pi r square. So pi r square plus pi r square, 2 pi r square. Now here there are certain things which you can take common. So let us take common and put it in simple form. 2 pi r you can take common. Here h left, here r left. So I'll write r in the front, r plus h. So Tsa of cylinder is 2 pi r plus h. Now volume. Similarly like before, area of the base into height. What kind of area it is? Circle. So what is the area of circle? Pi r square. So here it will be pi r square into height. That is pi r square h. Very easy to remember. Now next figure we have is cone. So when we call cone, see, this is a cone. At home you might be used to with a birthday cap. So that is also a figure of cone. Ice cream cone, that is also a figure of cone. So in a cone there are basically two types of height. You can see here it's not a straight, unlike cylinder. Cylinder it's a straight height, that's why only one edge. But here it's a slanted. So that's why one height we have slant height and another height vertical height from middle. So here in the figure you can see this line is vertical height, which is from inside. We cannot see in this figure. And outside this side is slant height and radius. Since it's a circle, radius is always involved in there. So similarly, CSA, if you find it out, it comes out pi RL. Try to compare between cylinder and cone. It's easy to remember. Cylinder is 2 pi RH, but here no H but L, slant height. And in cylinder there is involvement of 2, here no 2. That's it. So pi RL. TSA, pi r bracket r plus l, exactly like cylinder. In place of h there is l, and there in cylinder there is 2, here is no 2. Easy to remember. For remembering I am telling you this formula, okay. And volume for cone is, this cone is always 1/3 of the volume of cylinder. 3 out of 3 part, 1 part is the cone, okay. So 1 by 3 pi r square h. Same, pi r square h is the formula for cylinder. It's 1/3. Okay. So this is for cone. Next we have sphere and hemisphere. So this is a sphere. Sphere, you can take example of tennis ball or ball, whatever you have at home, football, whatever you at home. There might be many balls available. So sphere is example of that. Those are the example of sphere. So in sphere there is only one face which you can see. There are not 2, 3 areas. Only one area. No curved surface area or no separate area. So that's why we call it in simple surface area. And since it is made up of a circle, there is involvement of r. Radius is there. So surface area of sphere is 4 pi r square. Area of circle into 4. And volume, only one surface area, no CSA, TSA separately. Volume of sphere, if you calculate like before, it will come out 4 by 3 pi r cube. Remember, it's r cube. Now here I want to tell you, SI unit is very important in this chapter. Area, CSA, TSA, surface area always comes out in centimeter square or meter square or kilometer square or whatever unit square it would be. But volume will always be in cube, like centimeter cube, meter cube, liter, cubic liter. So now just like sphere, we have hemisphere, like the last shape of this chapter. Hemisphere is like a bowl kind of shape you might have at kitchen where you eat soup and all. And even if you take a ball and cut it in half, you'll be getting 2 hemispheres, okay. So hemisphere, since it is made up where the circle involvement is there, that's why radius comes up there, okay. And it has 2 faces. See, this curved part and upper part. So that's why it has CSA and TSA. Now for CSA, for sphere, its whole surface area is 4 pi r square, and if you cut it in half, then remaining half part surface area will be obviously half of 4, that is 2 pi r square. That's why CSA is 2 pi r square for hemisphere. Now when we say TSA, for TSA 2 pi r square also will take, and upper part also, that is another pi r square. So 2 plus 1, 3 pi r square. And volume will be, for sphere, its volume was 4 by 3 pi r cube. Then for hemisphere, it would be half of that. That means half of 4 is 2. So 2 by 3 pi r cube. Here also cube involvement is there, like the volume concept. Okay. So by this, concept of surface area and volume is over. If you get confused, keep on going through how the formula has been calculated again and again. Write the formula in a fair copy and then keep memorizing it, because it's very important for 9 and 10 both, and even for higher classes also. This concept keeps on coming for surface area. Okay. So now we'll be going through question answers. I'll tell you how to solve it out few questions and then we'll try to wrap it up. Okay. Exercise 13.1, question number 1. It says a plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. That means length, wide means breadth, deep means height has been given. So L, B, H is given. Clearly it's a cuboid. So always write a given like this and write length L is 1.5 meter, breadth B is 1.25 and height, depth means height, remember, 65 centimeter. It is open at the top. Ignoring the thickness of the plastic sheet, determine area of the sheet required for making the box and also the cost to make it. For rate is given. Let us first find area. Now clearly a concept has been said. It is said you are going to make a box using this length, breadth, height, but it is open at the top. But it's open at the top. So top is not there, excluding this upper part. This is not there. That means LSA and bottom is required. We don't need top. Getting my concept? So that is very important, what you are going to calculate. So end of the day, either you will be using LSA or TSA, but addition and subtraction would be there in certain questions. So like for this example, in this question, top is not required. So either you can do TSA of this figure minus area of the top, or you can do LSA plus area of the bottom. Both are correct. Okay. Now, but before you start it up, always see the SI unit. Meter, meter, centimeter. Then centimeter, you have to convert it to meter. 65 centimeter, you want to convert to meter, you'll divide by 100. Now that is 2 zeros in the denominator, point will come before 2 digit. That is 0.65 meter. Now we have all LBH. Now let us find the area. Number 1, required area. Why required area? Because they are asking us not to include a certain part, that's why. So here question is, find the area required to make for that box excluding the top. That means LSA of cuboid plus area of bottom. Clear? Now LSA of cuboid, we have already used formula. We have memorized it also. It is 2L plus B into H plus area of the bottom. What kind of figure it is? Rectangle. So area of rectangle is length into breadth. So LB. Now let us put the value. In place of L it would be 1.5, B would be 1.25, H would be 0.65 plus L is 1.5, 1.25. Very simple. In this chapter, even if you write given correctly and use the correct formula, you will be getting half mark. We call it stepwise marking in CBSE. That's why it's very important to know how to write given and utilize the correct formula. Now, how to add and subtract when there is a point. That I'll be re-explaining it to you, which you have already learned though. So first let us try to bracket off 1.25 plus 1.5. 1.5. Whenever you are adding, points should be in its own respective places. So do not change places. Do not put 5 here, point here, 1 here. Not like that. Okay, point in its own respective place, add them. Nothing means there is 0. So 5 plus 0, 5. 5 plus 2, 7. 1 plus 1, 2. Okay, so 2 into 2.75 into 0.65 plus 1.5 into 1.25. Now let us multiply this 3. 2.75 into 2. 2, 5, 10, 0, 1, 7, 14, 1, 15, 5, 1, 2, 2, 4, 5. After, just think there is no point and multiply with 2 regularly. After multiplying, check the point. After point there are 2 digits, then before 2 digits you put point. Okay? Into 2 done. Now again multiply with 0.65. 0.65. Now just think there is no point. Multiply with 65. How you would be doing? Do the same method. 500, 55, 25, 27 here. 6 0 is 0, 6 5 is 30, 0 3, 6 5 30, 33. Okay, with 0 no need to multiply. Okay, and then add them. 0, 5, 7, 5, 3. After this count point. After point there is 1, 2, 3, 4 digit. That means 1, 2, 3, 4 digit ahead there will be point. That means 3.575. No need to write that extra 0. 3.575 plus those two also let us multiply in the same way and write 1.25 into 1.5. Just think there is no point in the beginning and multiply. 5, 5, 25, 5 to 12, 5, 1, 5, 6, with 1, 5, 2 and 1, add them. And after point 1, 2, 3 digits. So 1, 2, 3 digit ahead point. So that means 1.875. Now finally we will be adding them. 1.875 plus 3.575. Add these two. 5, 5, 10, 0, 7, 7, 14, 5, 15, 5, 6, 8, 14, 3, 4, 5. 5.45. Meter square. 0 no need to write. That means the first one. I'll be rubbing this part, okay? I hope you are very clear with multiplication concept when there is point. So you have found the area. Now your question continues. Number 1 is over. Second one, find the cost of the sheet for it if the sheet measuring 1 meter square cost rupees 20. Whenever for certain smallest unit, like for 1 meter square, certain rupees is given, certain amount is given, we call it rate. So that rate is given in your question. Rate big R is equal to rupees 20 per meter square. Because it is say in 1 meter square it is costing 20 rupees. So let us find the cost. Cost. I'm going to give you one more formula. Whenever in the question while continuing ever there comes find the cost, or whenever cost and rate is given, there is always one fixed formula. Cost is equal to rate into area, or if it's volume then cost equal to rate into volume. So cost equal rate into area. Rate is given 20, right there 20. Area we have just found 5.45. Multiply them. 1 0 cancel, point will go after. 1 digit, 54.5. 2 5 is a 10, 1. 4 to 8, 1, 9. 5 to 10. After point 1. So that means rupees 109. Point 0 is there, after point no need to write. So this is how we calculate it, okay? Now in this way you can continue other questions also. For exercise 13.1, you can exclude question number 7 where the percentage involvement is there. Such type of question has been removed from CBSE, so no need to worry about those type of question. And number 2, I'll give you a quick hint how to go about. You can do it by yourself. Number 2, length, breadth and height of the room are given 5, 4 and 3. Length 5, breadth 4, height 3. Find the cost of whitewashing the walls of the room and the ceiling at the rate. Rate is given. Rupees 7.50 per meter square. So this type of question is important. Let us work it out. It is clearly said find the cost for whitewashing 4 walls and the ceiling. That means LSA plus area of top, that is rectangle. So let us find that area. Required area would be LSA of cuboid plus area of top, that is ceiling. LSA formula 2 L plus B H plus LB. Put the values. 5, B is 4, H is 3, 5 and 4. 5 plus 4, 7. 7 into 2, 14. 14 into 3, 12, 42 plus 5 into 4, 20. 62 meters square. Okay? Now your question doesn't end there. They are asking you to find cost. So right now I have told you cost is equal to rate into area. Rate is 7.5. Area is 62. Multiply them like before, whatever rupees comes, that is your answer. Like that you can do question number 4 also, 5, 6, you can omit 7 and 8. You can do 8, you can do. But for question number 3, a bit twisted one, that I'll do it for you. Okay? So question number 3 is the floor of rectangular hall has a perimeter. Here perimeter of that cuboidal hall is given. So perimeter is 250. If cost of painting the 4 walls at the rate of rupees 10 R is given and the cost is rupees 15,000. Read the statement very carefully. Yeah? In this type of question you often write the given wrong. So because you have problem in understanding the statement. The statement says if the cost of painting the 4 walls at the given rate is rupees 15,000. Focus on that one. So that means cost is given as 15,000. Rate is also given. Your question is find the height of the hall. H will be what? Now cost and rate is given, so let us use that formula. Cost is equal to rate into area. Cost is 15,000. Rate is 10. So 0 will come and divide, 10 will come and divide. 1 0 cut out. That means A we got 1500. But what kind of A it is? In cuboid we have just learned CS, LSA and TSA. So what area it is? Focus there, not only A. Since it is said 4 walls have been painted, this area is LSA. So here LSA ka formula you will be using. What is the area of LSA of cuboid? 2 L plus B into H. Now 2L plus B is clearly the perimeter of a rectangle. Before, while finding out the formula also we have done. So here 2L plus B perimeter is 250. So in its place clearly directly 250 you can write. 250 into H remains there is equal to 1500 remains there. Okay. After that you can find H. 250 is multiplied, it will go and divide. So 1500 by 250. 0 0 cancel, divide with 5, 5 3 15 0, 5 5 25 and finally 5 6 is 30. That means height is 6 meter. Like this, please complete exercise 13.1 fully.